Picture this, a giant spaceship the size of a football field soaring around our planet. That's the International Space Station, or ISS for short. This incredible feat of engineering is not just big, it's been home to astronauts from all over the world for over 20 years. The ISS circles Earth every 90 minutes, traveling at a speed of over 17,000 miles per hour. Can you imagine looking out the window and seeing our planet whiz by below? The ISS is a place where we're pushing the boundaries of science and technology, learning how to live and work in space for extended periods. Think of it as a giant laboratory in the sky, where astronauts are conducting experiments that could change the world. Building something this complex in the harsh environment of space was no easy feat. It took the combined efforts of over 15 countries, each contributing their expertise and resources. Imagine the challenges of coordinating teams from all over the world, speaking different languages and working across different time zones. The dream of a space station, a permanent outpost in the cosmos, had captivated imaginations long before the ISS took shape. But turning this dream into a reality required a bold vision and unprecedented global cooperation. In the midst of the Cold War, a time of geopolitical tension, the seeds of the ISS were sown. It began with smaller space stations, like Skylab from the United States and Mir from the Soviet Union. These early endeavors, though limited in scope, provided valuable experience and knowledge that would later prove invaluable. Could we actually build something in space, something that could withstand the harsh conditions and provide a platform for scientific discovery? The answer, as we now know, was a resounding yes. The lessons learned from Skylab, Mir, and other early programs paved the way for a more ambitious project, one that would require multiple nations to pool their resources and expertise. The International Space Station, as the name suggests, was never intended to be a solo mission. Right from its inception, the project was conceived as a partnership between nations, each bringing its own unique strengths to the table. The United States, with its experience from the Apollo and Space Shuttle programs, played a leading role. However, it was the inclusion of other spacefaring nations that truly gave the ISS its international character. The European Space Agency, representing a consortium of European countries, brought their expertise in spacecraft design and robotics. Japan, with its prowess in technology and miniaturization, provided crucial modules and scientific equipment. Canada, known for its expertise in robotics, contributed the Canadarm2, a robotic arm crucial for assembling and maintaining the station. And then there was Russia, with its legacy of long-duration spaceflights, providing essential modules and launch vehicles. This diverse coalition, bound by a shared vision of space exploration, laid the groundwork for an unprecedented international collaboration. Each nation, with its unique capabilities and cultural perspectives, contributed to the tapestry of the ISS. This spirit of cooperation was not just about building a space station, it was about building bridges of understanding and fostering a shared future among nations. Building the most complex structure ever assembled in space was never going to be easy. The path to the stars, as with any ambitious endeavor, was fraught with challenges, both technical and political. One of the biggest hurdles was simply coordinating such a massive project across multiple nations, each with its own bureaucratic systems and priorities. Funding was another major obstacle. Space exploration is notoriously expensive, and securing the necessary funds from multiple governments required sustained political will and public support. There were moments of doubt, times when the project seemed on the verge of collapse due to budgetary constraints. Then there were the technical challenges. Designing and building a structure that could withstand the harsh conditions of space, from extreme temperatures to micrometeoroid impacts, required groundbreaking engineering. And let's not forget the logistics of transporting massive modules into space and assembling them with absolute precision while orbiting Earth at thousands of miles per hour. Overcoming these challenges required not just technical prowess, but also unwavering determination and a shared belief in the importance of the mission. November 20th, 1998 marked a pivotal moment in the ISS saga. Atop a Russian Proton rocket, the Zarya module thundered into the pre-dawn sky from the Baikonur Cosmodrome. Zarya, equipped with propulsion and power, was a critical stepping stone. It provided initial life support and guidance. Weeks later, Space Shuttle Endeavour embarked on a mission. Within its cargo bay rested Unity, the American-built connecting module. Astronauts had to capture Zarya and connect it to Unity. This intricate maneuver marked a turning point. It signified the union of two nations in pursuit of a common goal. the ISS was proving humanity could achieve the extraordinary when united. With Zarya and Unity linked, a new phase in the ISS's construction began, one marked by a steady stream of spacewalks and module additions. The astronauts, pioneers of a new era, braved the unforgiving environment outside their spacecraft, spending hours tethered to the ISS, their spacesuits their only protection against the vacuum of space. These spacewalks, broadcast live to an awestruck world, became symbolic of the ISS endeavor itself, daring, complex, and requiring meticulous precision. Imagine the astronauts suspended between the Earth and the infinite expanse of the cosmos, their gloved hands manipulating tools and equipment with the utmost care. Each bolt tightened, each cable connected, brought the station one step closer to completion. As the ISS grew, so too did its complexity. New solar arrays, vast wings unfurling in the sunlight, provided the lifeblood of the station electricity. Habitability modules offered astronauts more room to live and work, while research laboratories equipped with cutting-edge technology opened up new frontiers in scientific exploration. Central to the ISS's design and functionality is its truss, a massive lattice-like structure that acts as the station's backbone. This intricate framework, spanning the length of a football field, provides structural integrity, supports the station's vast solar arrays, and serves as a railway for the mobile servicing system. Assembling the truss in space was a monumental undertaking, requiring astronauts to piece together massive segments with the precision of watchmakers. Imagine the scene: astronauts suspended hundreds of miles above Earth, meticulously aligning and bolting together these enormous truss segments, their every movement choreographed and monitored by teams on the ground. The scale of the task was immense, the margin for error razor-thin, yet despite the challenges, the truss gradually took shape, a testament to the extraordinary skill and courage of the astronauts and the tireless dedication of the global team supporting them. The truss is more than just a structural marvel, it's a symbol of the interconnectedness of the ISS project itself. Just as the truss segments are interlinked to create a strong and stable framework, so too are the nations involved in the ISS, linked by a shared vision and a commitment to collaboration. With each successful truss installation, the ISS grew not only in size but also in its ability to support more complex scientific experiments and accommodate larger crews, paving the way for even greater discoveries and pushing the boundaries of human knowledge. Among the many modules that make up the ISS, the Destiny module holds a special place. Delivered to the station in 2001, Destiny houses the American Laboratory, a state-of-the-art research facility that has become a cornerstone of the ISS's scientific endeavors. Imagine a laboratory where gravity is practically non-existent, where you can study the effects of space on materials, fluids, and even the human body in ways impossible on Earth. Inside Destiny, astronauts transformed into orbiting scientists conduct experiments across a wide range of disciplines. They study the growth of crystals in microgravity, hoping to unlock secrets that could lead to new materials for everything from computer chips to aircraft wings. They experiment with growing plants in space, a crucial step towards developing sustainable life support systems for long-duration missions to the Moon and Mars. They even examine how the human body adapts to prolonged spaceflight, analyzing bone density, muscle atrophy, and cardiovascular changes, with the goal of mitigating the health risks associated with space travel. The knowledge gained from these experiments isn't just for astronauts, it has the potential to improve life here on Earth. For example, research on osteoporosis conducted on the ISS has led to new treatments for the condition here on Earth. Life on the ISS is unlike anything on Earth. Imagine waking up to a sunrise every 90 minutes, Earth a breathtaking sphere against the black void. Living in this extraordinary environment presents unique challenges. Astronauts adapt to confined spaces and constant life support hum. Daily routines, from brushing teeth to exercising, are relearned in microgravity. Food comes in dehydrated packages or pouches, far from home-cooked meals. Despite challenges, life on the ISS is filled with awe and wonder, changing perspectives on our place in the cosmos. The International Space Station is a dynamic and evolving structure, constantly upgraded to accommodate new experiments and technologies. Imagine a construction project that never ends, orbiting Earth at thousands of miles per hour. New solar arrays boost power supply, supporting complex experiments. Commercial cargo spacecraft revolutionize station supply, making missions more frequent. These advancements enhance scientific capabilities and test technologies for future missions. The ISS plays a pivotal role in shaping our future among the stars. Section 1. Humanity's first space home. The year 2000 marked a pivotal moment in human history. For the first time, a permanent human presence would grace the cosmos. The International Space Station welcomed its first long-term residents. The world watched as a Russian Soyuz spacecraft docked with the space station. On board were William Shepard, Yuri Gidzenko, and Sergei Krikalev. These astronauts were the first to call the ISS home, their mission to make the ISS a vibrant hub of scientific discovery. Setting foot in a new world. The International Space Station, at the turn of the millennium, was a far cry from the bustling space laboratory it is today. For the expedition, one crew, stepping aboard meant acclimating to a new reality, where every movement was a delicate dance with microgravity. The station, still in its early stages, was a symphony of whirring machinery and blinking lights. Imagine the surreal experience of floating freely, their footsteps no longer bound by Earth's gravity. Every task became a unique challenge, a ballet of coordination and adaptation. Surrounded by breathtaking views of Earth, they were constantly reminded of our planet's preciousness. Life aboard the International Space Station wasn't just about groundbreaking science and exploration, it was about adapting to a new way of life. Daily tasks took on new dimensions in space. Exercising for 2 hours every day was crucial for maintaining muscle and bone mass. Even sleeping took on a new form, with astronauts securing themselves in sleeping bags. They spent hours gazing at Earth, captivated by its beauty. Their experiences provided invaluable insights into the psychological and physiological effects of long-duration spaceflight. For over 2 decades, this orbiting laboratory has circled our planet, symbolizing international collaboration and scientific endeavor. Astronauts from different nations work side by side, showing that political differences melt away with a common goal. We've learned to live and work in microgravity, conducting experiments that yield invaluable insights. As we look to the future, the legacy of the ISS will guide us, reminding us of the power of collaboration and human potential. The International Space Station is a symbol of hope and inspiration for people around the globe. Its presence reminds us that humanity can achieve extraordinary things together. The ISS stands as a beacon of unity, transcending political boundaries. It reminds them that the universe is full of wonders waiting to be discovered. The ISS inspires a love for science, technology, engineering, and mathematics. It fosters international cooperation and understanding. The ISS reminds us we share a common home and responsibility to protect our planet. The legacy of the International Space Station will shape our destiny among the stars. The knowledge gained and technologies developed will serve as stepping stones beyond low Earth orbit. The ISS has taught us invaluable lessons about long-duration spaceflight and human adaptability. Imagine the Moon as a stepping stone for missions to Mars and beyond. The ISS has paved the way, showing that international collaboration can make the impossible a reality. The ISS has highlighted the importance of commercial partnerships in space exploration. Private companies like SpaceX and Blue Origin are lowering the cost of access to space. Thank you for watching Time Pilgrimage, and as always, please remember to subscribe and like. If there is a topic that you would like to explore, please drop a comment.